Welcome to all dear students in Gokul Global University. Today we discuss about our continuous topic UV spectroscopy in part 5 with some UV spectral example with solved problems. So here first we discuss about the Woodward-Fieser rules which are applicable for the examples of the UV spectra. So Woodward-Fieser rule, it is used for calculating the absorption eczema. Woodward gives certain rule for correlating lambda max with the molecular structure. This rule for calculating lambda max in conjugated dienes, trines, polines. So there are two diene systems are present here. The first is homoannular dienes, cyclic dienes having conjugated double bonds in the same rings. Here you see there are two double bonds are present in the same ring, so it's called a diene system in the same ring, then it's called a homoannular dienes. Now the heteroannular diene system are present in the two different cyclic ring. It's also known as a heteroannular dienes. Here you see two double bonds are diene system is present in the two different cyclic ring. Now the endocyclic double bonds, it is the double bond present in ring as shown. Double bond present in ring, exocyclic double bond. So here exocyclic double bond in which one of the double bonded atom is the part of the ring system. Here the double bond, the another double bond is part of the ring system. It's known as the exocyclic double bond. There are some values for the Woodward-Fieser rules for conjugated diene systems. The first is a parent values. If the structure contain acyclic and heteroannular conjugated dienes, then the value is 215 nanometer. If structure contain homoannular conjugated dienes, then the value is 253 nanometer. Acyclic trine, then the value is 245 nanometer. Increments. Some other increments which attached with the structure or the present in the structure, then the value is each alkyl substituent or ring residue value is 5 nanometer. Exocyclic double bond value is 5 nanometer. Double bond extending conjugation value is 30 nanometer. Oxochrome, there are many types of the oxochrome present in the structure. Then if OR oxochrome present, then value is 6 nanometer. For SR 30 nanometer. Chlorine bromine 5 nanometer. NR2 60 nanometer. OCOCH3 0 nanometer. Here it's a basic example for the UV spectral problems. Structure of the 1,4-dimethyl cyclohex 1,3 diene. Here parent value for homoannular dienes because the both double bonds are present in the same cyclic ring, then the value is 253 nanometer. There are two alkyl substituents are present here, so 2 into 5 equals to 10 nanometer. Two ring residues, here two ring residues are present here, then the 2 into 5 is equal to 10 nanometer, then the calculated value is 273 nanometer. Now Woodward-Fieser rules for dienes. There are more examples are present here for the Woodward-Fieser rules for dienes. Here word use a transoid and the cissoid. So when the conjugated system is like a trans, then it's also called as a transoid. It's a heteroannular system, or the both bonds are in the same ring, then it's system like a cis, then it's known as a cissoid. So transoid base means heteroannular system base, then the value is 240. There are one ring residue present here, three ring residue present here, 1, 2 and the 3. Then the 3 into 5 is equal to 15. One exocyclic double bond are present here, then the value is plus 5, then the total value is 234 and the observed value is 235. Same in this example, transoid base 3, then the value is 14 nanometer. Ring residue 3 presents are here, then the value is 3 into 5 15. One exocyclic C double bond C, then the value is plus 5. OR, then the value is plus 6. So total to 40 nanometer and observed rate to 41 nanometer. In the third example, transferred system, then the value is 240 nanometer, ring residues, 3 ring residues present here, then the value is 3 into 5 is equal to 15, alkyl substituent 1 present here, then the value is plus 5, 1 exocyclic double bond is present here, then the value is plus 5, then the total value is 239 nanometer. In the fourth example, here the system is a sinusoid or the homoannular system. Then the value is homoannular system is a 253 nanometer. There are three ring residue present are here, 1, 2, 3. Then the 3 into 5 is equal to 15. 1 exocyclic double bonds are present here. Then the value is plus 5. Then the total value is 273 nanometer and the observed value is 275 nanometer. In the fifth example, it's also as a sinusoid system. Then the value is 253, 3 ring residue present here, 1, 2 and the 3. Then the value is 3 into 5 is 15, 1 exocyclic bond, 3 double bond C bond present here, then the plus 5 value. Double bond extending conjugation is also present here, then the plus 30, then the total value is 303 nanometer. In the sixth example, the base value is 214 nanometer, 2 ring residue present here, then the plus 10, exocyclic C double bond C also present here, then the plus 5, then the total value is 229 nanometer. Now the base value in this structure, sixth number example, 240 nanometer for the base value, 2 ring residue present here, then the 2 into 5 is equal to 10, exocyclic C double bond C1 bond present here, then the plus 5, total 229 nanometer, observed is 236 nanometer. Now in the seventh example, there is no cyclic ring present here, then the base value is 240 nanometer, 3 alkyl groups are present here, 1, 2 and the 3, it's 3 into 5 equal to 15, then the total value is 229 nanometer. Observed value is 232 nanometer. Now in this structure, same, there are 4 alkyl groups present here, then the 5 into 4 is equal to 20, total is 234 nanometer, observed is 235 nanometer. 4 alkyl groups present here, the base value is non-cyclic, then the 240 nanometer. In the 8th example, base value is 253 nanometer, 4 ring residues present here, 1, 2, 3 and 4, then the 4 into 5 is equal to 20, 2 exocyclic double bonds are present here, then the 2 into 5 equal to 12, then total value 283 nanometer, observed is 282 nanometer. Now here also base value is 253 nanometer, 5 ring residue present here, 1, 2, 3, 4 and the 5, then the 5 into 5 equal to 25, there are 3 exocyclic double bond present, 1, 2 and the 3, so 3 into 5 equal to 15, DEC also present here, then the plus 30, then the total value is 323 nanometer, observed is 325 nanometer. Now Woodward-Fieser rules for also Diene, then the base values of the enol and dienol absorption systems. Acyclic alpha beta unsaturated ketones will be present, then the value is 215 nanometer. 6 membered cyclic alpha beta unsaturated ketones present, then the value is 215 nanometer. 5 membered cyclic alpha beta unsaturated ketones, then the value is 202 nanometer. Alpha beta unsaturated aldehydes, then the value is 210 nanometer. Alpha beta unsaturated carboxylic acid and ester, then the value is 195 nanometer. Double bond extending conjugation DEC, then the value is same, plus 30. Exocyclic double bond plus 5, same. Homodyne component plus 39. This is a Woodward-Fieser rule for enones. There are the value of the enones. Alkyl group ring residue, if the position at the alpha, then the value is plus 10. If the beta, then the value is plus 12. If the gamma and the higher, then the value is plus 18. In the polar group, OH group is present in the alpha position, then the value is plus 35. At the beta position, value is plus 30. At the delta position, value is plus 50. AEC group, then the alpha beta gamma same, then the value is plus 6. Methyl group, then the alpha beta gamma delta have the continuously plus 35, plus 30, plus 70, plus 31. Alkyl groups present, then the beta position, then the value is plus 85. Chlorine at the alpha position and the beta position continuously plus 15, plus 12. If bromine, then alpha beta have the plus 35, plus 30, plus 25 and the plus 30. And the NR2 group, then the beta position, then the value is plus 95. Now Woodward-Fieser rules for enones. Now the base value is 250 nanometer, alpha substituent, then the value is plus 10, and the beta substituent, then the value is plus 12. Then the total is 237 nanometer, observed is 232 nanometer. Here also system base, then the value is 215 nanometer, 2 beta substituents here present here, then the value is plus 24, 12 into 2. 1 exocyclic C double bond C present here, then the value is plus 5, then the total value is 244 nanometer, observed value is 245 nanometer. In this structure, base value is 202 nanometer, beta substituent, then the plus 12, and the alpha OH, then the plus 35, then the total value is 249 nanometer, observed 247 nanometer. Now in the fourth example, base value is 215 nanometer and the 2 beta substituents present here, then the value is plus 24, alpha OH present here, then the plus 35, then the total value is 274 nanometer, observed value is 270 nanometer. Now here some more example for the Enones system. Base value is 215 nanometer, 1 DEC, then the value is same, plus 30. Homocyclic diene 5 ring member, then the value is plus 39. Residue total, then the plus 18. Observed value is total value is 302 nanometer and the observed value is 300 nanometer. In the second example, base value is 202 nanometer, exocyclic C double bond C present here, then the value is plus 5. 2 beta position ring residue, then the value is plus 24, then the total value is 231 and the observed value is 226 nanometer. Basic value if alpha position bromine present here, then the value is 202 nanometer is the basic value, and the alpha position bromine value is plus 25. 2 beta ring residue present here, then the value is 2 plus 24. Exocyclic C double bond C present also here, then the value is plus 5. Then the total value is 256 nanometer, observed value is 251 nanometer. Now the base value for the fourth structure, there is a 250 nanometer, beta ring residue also plus 30, delta ring residue it's also plus 12, 2 exocyclic C double bond C, then the plus 18 and the plus 5. Then the total value is 280 nanometer and observed value is 280 nanometer. Here Woodward-Fieser rules for the enone. Another example. The first example, the base value is not cyclic ring, then the 215 nanometer alpha alkyl substituent, then the value is plus 2 here present, then the beta alkyl substituent, then the plus 12, then the total value is 237 nanometer. In the second example, base value is 215 nanometer, alpha alkyl plus 10, beta alkyl plus 12, then the total value is 237 nanometer. Base value is 215 nanometer, 1 DEC also present here, then the value is plus 30, 1 exocyclic double bond present here, then the value is plus 5, beta alkyl substituent, then the value is plus 12, gamma alkyl substituent, then the value is plus 18, and the delta alkyl substituent, then the value is plus 18, then the total value is 298 nanometer. Here also base value is at 215 nanometer, 1 alpha alkyl group, then the value is plus 10, 2 beta alkyl group, then the plus 24, 2 exocyclic double bond, then the value is plus 10, then the total value is 259 nanometer. For the aromatic compound, there are some different values given here. If aromatic carbonyl group, then the 246 nanometer, aldehyde group, then the 250 nanometer, carboxylic or ester group, then the 230 nanometer, alkyl or ring residue in the ortho meta position, then the plus 3 nanometer para position plus 10 nanometer. OH or CH or alkyl group at the ortho meta position plus 7 nanometer and para position, then the plus 25 nanometer. For the amine group ortho meta position plus 30 nanometer, on the para group para position plus 58 nanometer. NaCO3 ortho meta position plus 20 nanometer, para position plus 45 nanometer. NHMe para position plus 73 nanometer. NMe ortho meta position then plus 20 nanometer and the para position plus 85 nanometer. Chlorine at the ortho meta position value is plus 10 nanometer, 0 nanometer, and the at the para position its value is plus 10 nanometer. Bromine have also same here, ortho meta position plus 2 nanometer and the para position plus 15 nanometer. Here some aromatic compound given. The methyl group are connected with here. Then the 246% parent chromophores value, 3 O ring residue, ortho ring residue, and the plus 25 para methonic acid present here. Then the total value 274 nanometer and the observation value 276 nanometer. Now violations of Woodward rules. Biphenyls 250 nanometer, 1 CH3 connected with the 1 ring, then the value is 237 nanometer. Again 266 nanometer, more alkyl group, not planar, 45 degree angle. Substituents cause loss of copolarity of orbital, loss of overlap, blue shift with reduced intensity. Now steric inhibition of resonance. In alkenes, trans isomers exhibit absorption at longer wavelength and high intensity. Woodward rules are applicable only if there is no strain around chromophore. Here the ring strain and the cross conjugation also present here. Steric inhibition of resonance. If calculated and experimental values of delta max do not match, one can say that the molecule must have some strain. Thus, UV can be used indirectly to determine if the molecule has any strain. So, it is a very useful advantages of the UV spectroscopy that we will calculate the or the know about the any type of the strain present in the structure by the UV spectroscopy.